We're going to take a look at the second part of a lesson on graphic form of a line. And in this case here, we're going to look a lot more at context and how we can use context to describe an equation and then create that equation taking context and creating an equation using graphic form. We're going to look specifically at graphic form today, and we're not going to worry too much about changing the general or another form called slope point form. We're going to look specifically at graphic form in this sense, and specifically at context that uses graphic form. So let's take a look at some examples. Today's will be just strictly looking at some examples of how we can use context and graphic form in that. Here's the first example we're going to look at. A cell phone plan charges a monthly fee that covers the cost of the first 300 minutes of phone use, and this graph represents the cost of the plan based on time beyond 300 minutes. All right, so first of all, I just have to preface this by saying this is an older example. I should probably change that to time used to maybe, data used or something along those lines, because no one ever talks on the phone anymore and all our calling is unlimited at this point, or maybe it isn't in your place. But things have changed a little bit, so it's a bit of an older example, but we can still use it as an example. So we know that we have a cell phone plan that has a base fee, and anything above that is going to be anything that you use above the certain number of minutes, in this case 300, is going to be charged a little bit extra. So on the horizontal axis there, normally the x, which we call it is called the n right here, we're told the time used beyond 300 minutes. So we're started at 300 minutes, and then any time used above is going to affect the cost, which is our vertical axis of the cell phone plan that we are going to use. So first question I'm going to ask is, how do you know that this graph is a linear function? You should be able to yell this out right away. It's a straight line. Yeah, it is a straight line. Okay, and that is going to mean that it is a linear function. It follows a linear pattern that as one variable increases, the second variable increases in this case as well because it's going up. Now, can we create a linear function? Well, we need to know the slope. But what does the slope of this graph represent? The slope of the graph represents the change in y, which happens to be the cost, over the change in x, which happens to be the time used beyond 300 minutes. So this one here, it represents the cost per time used above 300 minutes. That's what the rate of change is. That's what the slope is in this case here. So that's something that's important that we know. Now let's write an equation to describe this function. We're going to use the form, the graphic form, which is y is equal to mx plus b. To find the slope, we need to know what the rate of change is, or the rise over the run of our function. Take 2 points. We have the first one there that's right at the beginning on the left-hand side, and then we have another one that's close to the end there, kind of on top at 100 minutes is equal to $50. So we know that 0 minutes above is equal to $20, and 100 minutes above is equal to $50. So our run in this case here is 100. Don't count the squares. Okay, each square in this case is 10, so it adds up to 100. And the rise from 20 to 50 is 30. Again, don't count the squares. Look at the difference between the two numbers. Very important that we do that. Now, what that's going to mean is that our slope is the rise, 30, over the run of 100, and we can simplify that to 3 over 20. And then the y-intercept, the cost, that base cost in this case here, is at 20. So our function is c cost, which we could also write as y, is equal to 3 over 10 n representing the number of minutes. You could also think of it as x plus 20. And that's going to give us our equation. So there we go. We now have an equation to determine the cost of the cell phone plan. Now, let's just verify that this equation is correct. Okay, we've done all the work. We hope it's correct. Okay, let's just verify, is it actually correct? Well, let's find another value that actually works right there at 50 minutes above and $35. So if this is true, we should be able to plug the x and the y values into our equation like that. Okay, so we plug the cost in for the cost and the number of minutes in for number of minutes, and let's solve for if it's correct. Well, 35 is equal to 3 over 10 times 50, which happens to be, that would be 15 plus 20. 15 plus 20 is 35. Perfect. It does work. Sorry I didn't confirm it there on the screen, but it does in fact work. If we solve both sides, we're going to get that both sides are equal to each other. So this equation works for more than just those 2 points. It works in fact for another point as well. And we could plug in the points that we used to solve, but it's nice to get a other point as well. Now let's look at another example here. The student council is sponsoring a dance. The ticket costs $5 and the cost for the DJ is $300. Let's write an equation for the profit based on the sale of the tickets. Okay, so we're wanting to write an equation. We're going to use graphic form again. We can. That is based on the sale of the tickets, and we're trying to solve for the profit. Well, that already tells us what our two variables are. X is going to represent the number of tickets sold, and Y is going to represent the total profit. Okay, so this is important that we know this. All right, now the profit is going to be based on the amount of money you've made on tickets sold. Well, that's 5, which happens to be our rate of change. For every person that's coming, we're going to have an extra $5. So we're going to multiply the number of tickets by 5. There's our rate of change. There's our slope, right? And then our base cost happens to be the cost of the DJ. So profit in that case, we are down $300. So our equation is going to be Y, the total profit, is equal to 5 times X minus 300. There we go. There's our equation. And we can graph it out, and it looks something like this. And I'm sorry that that's a little bit small, but it shows the that base cost, okay, with no tickets sold. It's going to have a profit of negative $300. But as we sell tickets, as we go up along the X value, okay, we actually have a more and more profit, or a higher and higher value for that profit. So we can use that to solve different questions as well. Here's the question. Let's suppose 123 people bought tickets for the show, for the dance. What is the profit? Well, we could use this and we can try to figure out exactly where 123 is and figure out where that value is, or we can use our equation. Let's use the equation. Yeah, perfect. Okay, so let's plug 123 people in for tickets, which happens to be our X value right there. Let's multiply that out. 5 times 123 is going to be $315. 5 times 123 minus 300 is going to be 315, which means that we have a $315 profit. Sweet, got it. Okay, so we can use an X value to solve for that, and that's going to be a point on our graph as well. Now, what if we have a profit of $350? How many people bought tickets? So this is going in the other direction. We know that, again, on here, we can look at where's 350. We can try to find it kind of based on the graph somewhere down. I'm going to go the other way here. Somewhere down there, yeah, roughly. Okay, trying to point it out. It's really hard to do this. I do it backwards. But we can figure out where it is there and then try to determine how many tickets were sold. Now, that's an estimate. We can do it exact as well by taking our equation and plugging the 350 into the Y value, because that's our profit. We add 300 to both sides to get 650 on that side, and then we divide by 5, and we can determine that 130 tickets were sold for the dance. All right, let's do another one here. Could we have a profit of exactly $146? Well, let's think through this. Can we have exactly $146? I hope you're saying no, we can't. The profit has to have be a factor of 5, okay, because the tickets are $5, and so and we can't have part of a ticket sold. We're always going to have a full ticket sold. So it's important to understand that we can't have those exact ones. This is where domain and range come in. Okay, so our domain is going to be whole numbers, and our range is going to end up being numbers that are divisible by 5, but really it could be anything else, unless someone gives an extra dollar to the cause. All right, so what is the domain and range of this equation? Well, here is our graph, and it's not super nice there, but we did kind of describe our domain. X is a part of the whole number system, no negatives, no decimals. It has to be a counting number, or 0, because we could have 0 people that come to the dance. And then our range, well, we're going to say that Y has to be greater than or equal to negative 300, because that's where it starts and it continues on, and maybe we can have a profit that's huge, depending on how many people come. We're not told a maximum, so we're just going to understand that it goes from -300 and above. I hope this video was able to help you. I hope it gives you some examples of how we can use context and graphic form, and all the best as you work through your questions. If you have any questions on that or you're unsure about things, please reach out or talk to me in class when you have an opportunity.